can't see Spider, you should be able to open up Anaconda Navigator. If you don't, you should just be able to do it through your start menu. So I use Spider. You can click launch here. Let's see if it'll launch. All right. Let's not do that. We're just going to close out of this. Close out of this. And now I have some code. Okay. On the left-hand side here, I have where I get to type. I get to type here. Your colors may be slightly different, but that's okay. View tools, preferences. I need to make this font bigger. Here we go. Font. Totally destroys it for anything I want to do. All right, can you see that now? All right. Yep, this is your IDE. So I get to type here. So the best way to probably start this is, let's just go hit enter a few times. I just dragged down some numbers. We'll just go I equals 5 and hit F5. I've now created an integer. I hit F5, which then means I ran this file saved in home Downey ontitled0.py, which is our first issue, right? Our first issue is we need to know how to put code into directories because we want to be able to access things. So I am going to go File, Save As, and I'm going to create a folder somewhere and save it as example1. So I don't care where you create a folder. But go ahead and create a folder. Oop, that's not where I want to be. Yeah, no, class notes, that's right. In class. I'm not going to do that. I'm going to do that here. All right. And now if I hit F5, it has changed my code to where I am. Right. And so now I can load data in from other directories, and I just kind of know where I am in the operating system. All right. If I click here, I have Help, Variable Explorer, Plots, and Files. I'm going to click Variable Explorer. And you'll see this big int 5. And this is what's so great about Python. I now have a Variable Explorer that I can play around with. Okay, so if I delete this and I have nothing on my code, and I hit F5, you'll notice that my integer is still here, right? And it's still here because I never asked it to be taken out of memory. In Matlab, you have a really cool command called clear that you can put at the top of your code. Anyone know what clear is? Really cool, right? We don't have that. I apologize. Everything's a bit harder. So we are going to create a command, and we are going to say import IPython, capital I, capital P, as IP. And this is a standard way that we import modules. We just rename it so it's a bit shorter. I'm going to go IP.get underscore IPython, all lowercase. Open and close parentheses, dot run underscore line underscore magic. Everyone likes magic. And now I've got to feed it a few options. I'm going to feed it a single parenthesis, and it actually popped up 2. Reset, and that created a string, but we'll talk about that later. And another string dash SF, like soft force. And that is clear. See, Matlab just says clear. Wouldn't it be nice to just have something that says clear? Why do in one line, one word, what you can do in 2 lines and multiple words? But that's just how it works. Again, Matlab is written for, for scripting and problem solving, and it's very well formulated for that. And so we are not that well formulated. All right, everyone able to get that to work? All right, now we're not gonna talk too much about what we're doing. Kind of like follow me with faith, and we'll circle back to what some of this means. Yeah, help your colleagues, and you don't want to fall behind in this, I promise you. So import. So I'm going to come up here and go import NumPy as NP. I'm just renaming NumPy as NP. Import SciPy as SP. So NumPy does matrices, SciPy does data processing. Import Matplotlib as MPL. Okay. Python is open source, created by a bunch of people in their basement who are not getting paid. Sometimes that means they don't show up to the planning meetings. Sometimes there are no planning meetings, right? And because of that, you have weird deviations in code that you just have to go with. There was 2 schools of thought in the Matplotlib library. One school of thought said, just copy what Matlab does. Let's do that. Another school of thought said, we are creating a new program. We should have new thoughts. They lost, right? So everyone who uses Matplotlib just uses the people who said, just follow Matplotlib. So import matplotlib.pyplot as MPL. This is as PLT, kind of the standard letters that people use. There is a whole different side of Matplotlib that does not use pyplot. I've never been there. I don't know what it looks like. A lot of people haven't been there. But that's why we have to do this .pl pyplot, because sometimes there's nuances to it that you kind of have to just understand and accept. Okay. Just as when I run my code, I want to clear all my former variables. When I run my code, I want to delete all of the prior figures that I created. Just for troubleshooting purposes, Matplotlib just says close or close, Matlab says close or close all. For us, we will have plt.close and then a string of all, and that will just close all of my figures. Now, the %% will create a new section. And so this is load data, and then just # will comment. This is a comment. Okay. On the homework 1 on Blackboard, you can go and download a file that is called mini project 1 vibration data.zip. And you're going to have to unzip that file, and then you're going to have to put that file in your directory where your code is, or a subdirectory of that. And now we're going to go class notes. Sorry, this is just where mine was, Python. So I put mine in a folder called data, and it's measurement txt. I'm going to open with Notepad QQ. Do you want to continue? Sure. See if it crashes my computer. All right, this is a lot of time series data. Just an endless amount of time series data. not endless, but it's a fair amount. And then we have a header. So I took this data 2020, January 15th, at 10:34 p.m. Yeah. And then it's just x value, which is time, and acceleration. Tells you your y units are meters per second squared. There's also a link to the GitHub you can download. So go ahead and download that. And then we need to load that into Python. And so we are going to go D is equal to just capital D for D data is equal to np.loadtxt. And now I need to put a string in towards where my data is. So I know which file I'm at. So this, I don't want to get too confusing, but if you come over here, because you can also type in your terminal here, you hit ls, I can see everything in it. And anyways, I can see what's in my directory. That's probably not the way to do it, right? But if you know how to play around with the terminal, you can see what's in your directory. And so I have my data from where I'm at. That's always from where your Python code is. I'm going to go data dash, come up here, vibration underscore measurement.txt. Okay. Many of you, most of you, I assume, are on a Windows machine. Many of you do not have file extensions enabled. That's how you can tell people who use their computers for code and who get to use their computers for like shopping. Yes.
Sorry, I think a lot of us are having trouble finding the file. I don't see it.
Yeah, it's started. Oh no, yeah.
Found it.
Download the PDF of the instructions.
Perfect.
Mine doesn't pop up.
Yeah.
Are you on assignment 1 or are you on mini project 1? There are assignments, which are assignments that are like weekly done, multiple choice, same, and then there's the mini projects. Okay, so you might have to enable extensions. I am going fast, I understand, but we will troubleshoot. You might have to enable extensions. Otherwise, you will end up with .txt. Now, what's going on there is Windows is a slightly weird operating system, and they try to hide the extensions and just give it to you in an icon. And so people will name their stuff vibration measurement.txt, but then there's already a .txt on there that's hidden. So you'll have to kind of enable that. You can ask the AI and it'll help you. And now I'm going to hit F5. And we'll wait a second, I guess. Has anyone made it?
When you text the data, was that the name of your folder?
Yeah, that's the name of my folder.
So you just have to type from where?
From where you are, correct. So here, example 1.py, we're going on a trip. It's like going to the ocean, right? And I go to the data, and I go in that, and then I have vibration measurement.txt. That make sense? Did anyone? Yeah, if you don't like sitting next to people, this is a class you're going to quickly learn that you like sitting next to people. So. Anybody here yet? All right, I'll just keep going and then All right, so value error could not convert string to float lab view. Well, that's a little weird, right? So let's open up our data set. And what we notice here is that our first line is lab view. It's saying, hey, I'm telling it, I want you to grab the data out of this file. And you're probably expecting it to be in like a tab delimited or comma delimited form. And say, oh, I get this thing lab view and I can't make that a float, right? I can't make that a number. Okay, well, that's fine because there's a lot of header information. So I actually just want you to skip, the first 23 rows. That seems logical, right? Let's just skip the first 23 rows. So I can come on down here, I hit comma, skip rows equals 23. Now it'll totally work. And, oh, maybe it did work. It worked. Okay, awesome. I guess I wasn't expecting it to work. And now I have data, right? And this is where Spider is great. I have an actual data explorer where I can do cool things. Like I can scroll down and the color is actually a function of my data. And you can kind of see it getting more purple. Okay, wow. Oh, there we go. There was something, right? So something happened around here because I can see the color change, right? So kind of cool. Another thing I can do is I can right click and I can go plot. And now it just plots my two lines. What do you think the blue one is? What do you think the orange one is? And we want to take a stab at what the orange line is?
Vibration.
Vibration. What do you think the blue line is then? Yeah, it's your time vector, right? So this x is 1.2 e to the 6 data points. And then the blue line is the time vector. But we probably want to plot vibration against time, right? That makes more sense. So we can definitely do it in one, but let's break it off into two. I'm going to go tt is equal to d, capital D, square bracket, colon, comma, 0. Python indexes at 0, right? So Matlab will index at 1. So the first column is 1. In Python, the first column is 0.
What button did you press to make that plot?
I right-clicked and I hit plot. And then the second data is AC is equal to D, comma 1. And that's my second column. And now I hit F5. And you'll notice it's running, but it's taking a while, right? It's taking a while because it has to clear all my data and reload all my data. But I might not actually want it to reload all my data every time. So I could just highlight the code I want it to run. I hit F9 and it'll just run that code. F9 runs what you highlight, and then F5 runs the whole script. Another cool thing, if you don't want to use your mouse, you can cursor up, hit Shift and hit End on your keyboard, and it'll highlight till the end of the line, and then you can hit F9. Or if you're at the end of the line, you can hold Shift and hit Home, and it'll highlight to the beginning of the line. And then you can hit F9. Probably the coolest thing you'll learn in this class. So, all right. So PLT figure creates a figure environment. Graduate students, who's interested in writing papers? All right. In America, what is the size of a sheet of paper? 8.5 by 11, right? You add 1-inch margins to that, your figures are 6.5 inches wide because we have good figures. We want them to take up the whole page. So what we want to do is not run into an issue where we are using completely ridiculous font sizes of 23 and shrinking it down and hoping it looks nice. We want to be intentional about our figure creation. So we are going to create a figure in the correct size And that way, when we define the correct font, it will show up in the same size and we don't have to do any resizing. How cool is that, right? So fig size equals another set of parentheses inside of that, 6.5 comma 3. I've just created a figure that is 6.5 inches wide and 3 inches tall. And it will show up down, oh, okay. So my figure shows up here in a plot that I can drag around, but yours will show up here. Some people really like that, and that's perfectly okay if you do. I won't judge you. But I'm not a fan. So go to Tools, Preferences, go to IPython Console, Graphics, and change backend to automatic. And then hit OK and completely close out a spider. Completely. Open it back up and run your code. And then you'll have a window that pops up. And you want the window because that way you can zoom in and zoom out of your data. So we've created a figure environment. If we hit F5, we get the figure like in the middle of the screen. To hopefully show up in a separate screen. If not, we'll come back to that later. You can also find it under this Plots tab. And then we are going to do plt.plot. And that's just going to open up a plot environment. Now we're going to do TT. That's going to be our data on our time axis. We're going to do AC. That's going to be our acceleration. We're going to close that. We're going to hit F5. And again, it has to load in the entire data set, which is why it takes a little bit of time, and then it loads it in. And now we have acceleration. Now, the cool thing about the interactive window is that we can open it up and scale it and look at it. You know, we can kind of zoom in and we can see, oh, look, I can start to see like the resolution of my digits, right? Data point, data point, data point, data point, data point. The number of things I could do if I wanted to actually add features to that, I could in a string just put a period, and then that will allow me to, instead of have a line, right, just have actual data points, which I can zoom in and kind of find the actual data points, right? So none of this is impressive if you come from a Matlab environment. Of course, every plot you can zoom in and interact with. But if you were to learn how to code from like a more programmatic computer science viewpoint, they don't always have interactive plots, right? That's just engineers use code differently than kind of, let's say, a computer science person would. Okay, so I can also plot multiple data points. I'm going to copy that, paste, just paste it 4 times. And let's just say I only have one channel here, but let's just say I had more than one channel. I could do like TT plus 1, TT plus 2, TT plus 3. And all this is going to do is give me 4 different channels or signals, right? I mean, in this case, I only have one channel. But what you'll notice is that it automatically assigns new colors to each successive channel. And these colors are black and white friendly, and they're friendly for people who are colorblind, you know, people that put a lot of effort into what colors these are. But sometimes we might want to add different line styles to this, and you will want to do this in your reports because you want to create plots that aren't easy for the reader to understand. And so we can create different line styles, comma, put a string. A dash will get you a solid line. A comma string parentheses will get you a colon, sorry, will get you a dotted line. Comma string dash dot will get you a dashed and dotted line. Oh yeah. And then comma string dash dash will get you a dashed line. So now if I do this, F5, I should have 4 different line types. Let's see if I did it right. A little hard to see. So let's zoom in. Yeah, there we go. So I've got 4 different line types. Right, I've got dash, solid, dotted, and dot dash. More helpful when you have other data sets. There's a lot of data here. But 4 different line styles just to help you make kind of black and white friendly plots. However, the most effective way to probably do multiple plots is we're going to need a label, right? So I can go label equals like data 1. I can do label equals data 2. I can do label equals data 3. I can do label equals data 4. Now if I run that plot, actually I guess I won't get a label because I have to create a legend up here. So I need to go plt.legend true, and now I'll create a legend. I apologize. Just plt.legend. You don't need to give it a true Boolean. And now I have a data set that's got a legend, data 1, data 2, data 3, data 4. You can do cool things like LOC equals to 3, and you can move it around. It tries to automatically place it, but if you don't like where it's at, you can move it around. Kind of all of those things. Okay. Plots often need grid lines, so that's plt.grid true. That'll give you grid lines. Take a look at that. Right, and so that kind of gives us a plot with some grid lines, something that we can start to interact with. All right, no plot's correct without labels, right? Otherwise it's just randomness. So plt.xlabel. So let's go time in units of seconds, and plt.y label. Well, acceleration in units of meters per second squared. All right. Now, what do you notice about my X label? It's not there. So how do we get the X label to show up? One way to do it is to drag this down until it shows up, but we had defined our figure size, right? We don't want obnoxiously large figures. That's something that go in undergraduate lab reports, right? So we need to force everything onto the same figure. It's a little bit just of how the coder works. So actually, if you go to the left too, you can get the y-axis one off. It builds the figure environment, and then it builds the plots, right? But because you built the plot first and then you add the labels, it won't automatically resize everything, right? Because Python goes line by line. We build the environment, we add the data, we add the labels. So now I need to add a little bit of code that just resizes it. And that's going to be plt.savefig. Sorry, that is not. plt.tight_layout, open and close parentheses. And now if you hit F5, it will shrink everything down into those parentheses. Okay, so this looks pretty good. The next thing I notice is this meters per second squared. That looks pretty tacky, right? I get it. The caret means that it's a subscript, but that's not what we're here for. We're here to actually impress people with our machine learning ability so they pay us more money, right? Or whatever the currency is of the future. And so we want to fix this. And Python makes that really easy by integrating a LaTeX editor into it. So who's used LaTeX? Wow, 2. Okay. All right. So LaTeX is a typesetting language used for kind of typesetting professional documents. I would encourage you to use it for your papers. Makes things look pretty and clean, and just it's a lot more efficient than Word, right? So if you want to write more papers, learn how to use LaTeX. And then LaTeX has something called math mode. And so we're going to put this into math mode. And we're going to put a $sign before and after. And that'll put it into math mode in LaTeX. And then that should give us a superscript. All right. Does anyone have any other issues with my legend, with my units? It's kind of like an annoying question. But in SI units, which meters and seconds are, SI units are not italic, right? So SI units are non-italic or normal text, and variables are italic. So we actually don't want the M and S in math mode. We just want the ℏ2 in math mode. So I'm going to move my $sign out and move it back, and then rerun it. And now we should have a very good looking plot. We're pretty happy with that. It's a cool plot. All right, we got units, we got time. Let's save the plot. All right, so now we can come here, we can hit save. And I guess it saved the plot. So let's see. I do not know where it saved the plot. I'm not really a big fan of clicking buttons if we don't have to, right? So maybe we can write a line of code that will automatically save the plot, because I'm going to be making lots of changes to this. And so maybe I want just a little bit of code to save it. So it's plt.savefig. And now I want a name. So my _plot_1. And now I can just highlight all of this and hit F9. And it'll save my plot as my plot_1. So if I scroll into this, this actually isn't too bad, but you notice how like the D's and the 2's are kind of blurry. It saved it at a very low DPI, right, which is dots per inch. And since we've set our figure at 6.5 inches by 3 inches, the DPI actually matters. So right now we're at 96 dots per inch. So maybe we want to make that clearer, right? So I can just come on down here and I can do comma DPI is equal to 300. And then now I have a much cleaner, look how much I can screw in on that D before it kind of gets blurry. So that's a much better quality image, right? What if I want to move this label just a little bit to the right? It can get tiresome. There's ways in code to do this. And sometimes I would actually advocate that you run some fairly sophisticated code to get yourself some nice figures. But sometimes you just a report and you want to move this a bit to the right. Might be nice if there was a way we could use our mouse for that, right? Or maybe we wanted super clear data. That comes with these other issues. But I'm going to show you that you can actually export this. I'm just going to copy this down. And what I'm going to do is export it as a .pdf. And now if I go to my folder, I have created a PDF version of this figure. Now what's cool about a PDF is they're portable document files. And all of the data is actually still in here. And so when I zoom in and zoom out, it actually re-renders the text. So you'll notice that that D is perfectly clean, right? It's not a raster image, it re-renders the text. Has anyone ever used Adobe Photoshop? Photoshop at all? GIMP? All right, anyone ever heard of Adobe Illustrator? Anyone ever heard of SVG, Scalable Vector Graphics? A few people. Okay, so if we open this in Adobe Illustrator, we can actually make changes to this figure. It's pretty cool. I don't have Adobe Illustrator, right? But there are open source versions, and Inkscape is a wonderful tool. It supports vector graphics. And I'm just showing you this to kind of help you with your reports. Hopefully it'll save you some time. And what you can do is you can just drag your PDF into Inkscape. You can do a Cairo import. And again, this is just, if it's something you want to do in the future, you can Google and it'll help you. You can ungroup it. And now you can grab individual components like this legend box, or maybe all of this, but not that, whatever, you get the idea. And you can move individual components around, right? I do not condone it. But let's say you wanted to not change data. We don't change data, but we change the line, the color line, right? You can click on this color line because it's a scalar vector graphic, and I can go ahead and change the actual line of that color, right? Can kind of make updates. Maybe there's small updates you want to make. You want to make a complicated figure. Another cool thing you can do is you can hit F2, and then you can actually get, again, not condoning changing data, but you can like get the data points, right? Maybe you just, a lot of times when I want to make a figure, I just use Python to create like a sinusoid. And I'm just trying to make like an exemplatory figure, like an example figure. Really cool to do. One last cool thing you can do, which is kind of scary to some people, people publish papers. They publish them in Word. They convert them to a PDF. They don't understand that the PDF saves all of this. And so you can download a PDF. You can import their figures into Inkscape. And sometimes you can remove labels and get to the original base figure that people thought they had no longer. Or I've had to recreate data from examples, from papers. You import it, you can get the actual data points, and then this is just a text readable thing. You make a little Python code, read through SVG, you can get actual data out. Two cases where this happened and had very severe consequences. One was in the Bush administration. Someone tried to redact information about a CIA spy, and they drew a black box over it, and someone just opened it up in Adobe and grabbed the black box and moved it to the left, right? So make sure if you're doing stuff like that, you're actually re-rasterizing it and not just putting a black box. Also allegedly happened in a recent court case with a former president where their lawyers just got sloppy, and that's how they redacted it. So yeah, so understand kind of how figures are made. It can be very useful. But yeah, so Inkscape's free, open source. You can download it, use it for this, use it for other things. But that's kind of the basics of pictures. I think you can do like, yeah, so yeah, right? Maybe you wanted to just make some like parallel stacks and something. I don't know, but sometimes it's good to do stuff through code. Sometimes you actually like want to use a mouse. Yeah.
How do you set like?
Oh yeah, great question. Close about saving. Okay, so let's do plt.xlim. Then we're going to do curly brackets, square brackets, and we'll talk more about that in the future. Like, let's go from 1 second to 5 seconds. Then you can do the exact same for y limbs. Yep, so nothing actually happens in there of interest. So let's say from -1 to 1 on the y and see what that looks like. Maybe we'll see something. Yeah, right? So there's some kind of vibration there.